Hello everybody, welcome back to the channel. Today we are going to be solving some stack questions, practicing stacks in C++ STL. This time ChatGPT has curated some very good questions, I think because stack is really popular for DSA and everything, so it was able to find some good questions for it, unlike other things such as pairs or DQ or something. So we will start from the first question. The first couple of questions should be easy enough. It might be difficult for you if you have not practiced stack before, but I will try my best to explain them to you. This is basically my first time practicing stacks as well. It's been an insanely long time since I last did any kind of stacks or anything. So now I will mute myself. You can also try solving the question along with me. Okay, so the first question was simple enough. We were just supposed to reverse a string using stack. So what you can do is, just a second, let me explain it to you clearly. So yeah, for example, let us take the default string that we got, hello, and let us take a stack called st. I'm making it like a container. So I will iterate the string from the start till the end, and I will keep pushing these into the stack. So it will become, first it will be h. So first we will have h here, then it will be e, then l, then again l, then finally o. So this will become the stack. Now what we can do is, we can continuously pop these elements. By the way, what you can also do is you can just create a separate string. I was just modifying it in the original one. I will explain the code in a second. But for example, let us say we have an empty string called result for now, right? So what you can do is you can start popping from the top and adding it to this result, pushing to the back. So first you are going to be popping O, adding it to this result O, and you will be popping L, it will become L, then again L, it will become L, then E, it will become E, then H, it will become H. So this is how you can do it. You can also modify the original string using indexes, starting from the first index. The topmost element that you're going to be popping is going to be the last element, and when you pop it and append it, not append it, replace it with the character at that particular index, then the string can be reversed. Let me show you the code quickly. So as we can see in this case, first I'm taking the input and then I'm creating the stack. Then I'm iterating the string and I am pushing each of the character in the stack. So on the top we have the very last character, and then I'm taking an index I and I'm running a while loop till the stack is empty. So what I'm doing in this case, at ith position of the string S, I am just replacing it with the top of the stack. You can also do it the way I have shown in Paint just now. You can create a separate result string, push it in that. You don't necessarily have to do it this way, but anyways, so this is how you solve this question. This was simple enough. Now we can move on to the next question. You can also try it out with me if you want to. And if you have any doubts regarding anything, you can just comment down below. Who knows, maybe I missed something and I might also learn something new by your comment. So now we can just move on to the next question. You can also start practicing it with me. Now I will mute myself. Okay, so we have solved the next question as well. In this question we had to check if we have balanced parentheses or not. So for example, for balanced parentheses, for each opening bracket there should also be a closing bracket. There can only be three types of brackets. So the first is the normal round bracket, second is the square bracket, and the last is the curly brackets. So for example, as we can see in this one, we have an opening bracket, an opening curly bracket, and an opening square bracket, and for each one we have closing brackets as well, and they have to be in order as well. So otherwise you won't be able to close it. For example, in this case it doesn't make any sense for it to be in this order, right? Because this is just weird, so this would not work. It has to be a valid order of parentheses, you can say. So I think let me explain it to you using paint. Just a second. So for example, we have a default one, this, then this, and it should be this, then this. So let us use a stack. We don't need a result in this case, and just put this away. So yeah, so we will take a stack, and if it is any of these opening brackets, if it is any of the opening brackets, these three, then in that case we will be pushing it to the stack. So for example, first we have this, so this is pushed to the stack. Then we have the curly opening bracket, this is pushed to the stack. Then we have the square opening bracket, this is pushed to the stack. And once we hit a closing bracket of any kind, so we have these three possible closing brackets. So first we hit the square closing bracket. What we are going to do is we are going to pop from the top. We will see the top of the stack. If this top is equal is the opening bracket for the closing bracket that we have hit. So for example, for a square closing bracket it should be a square opening bracket. For a curly closing bracket it should be a curly opening bracket, and so on for each one of them. So if we have these, then this is a valid parenthesis. This works fine. But otherwise, for example, if in a case we had a curly closing bracket and we have a square opening bracket, this does not make any sense. So this is not balanced, so in that case we will be returning not balanced. So let me just complete the current test case that we are on, and then I will explain the non-balanced case as well. So we have this works correctly. Then we hit curly closing bracket. For the curly closing bracket we have a curly opening bracket, this is correct. And then we hit a round closing bracket. For the round closing bracket we have the round opening bracket, so this is correct as well. So we can see this is once we have reached the end of this, and we can see that the stack is empty as well. So now we know that it is a balanced parenthesis string. And in a different case, so let me show you the other test case that we had as well. So the other test case is this. So first is an opening bracket, so we will push it to the stack. Again an opening bracket, we will push it to the stack. Then we have a closing bracket. So for this closing bracket, is a round closing bracket. We will be seeing the top of the stack. It is a square opening bracket. So this does not make any kind of sense. So we will just return a non-balanced parenthesis string. So this is the way we are supposed to solve this. So for each closing bracket there should be the corresponding opening bracket accordingly in the stack. Only then it is a valid parenthesis, otherwise not. So let me show you the code now to explain it to you. So what I am doing in this code is I just created a function to return the particular string that we need as the output, which is balanced or not balanced accordingly. So first I created the stack, and then I am iterating the string, each looking at each character. If the character is an opening bracket, so this is the condition for opening brackets. We just take these three conditions using the OR operator. So we just push it to the stack. Otherwise we check if the stack is empty. So otherwise we have only obviously the other possibility is that we have a closing bracket, although you can change it accordingly if your input is going to be a bit different. In my case I am just leaving it like this, so I am not doing any kind of error handling. For example, if there are white spaces in between or maybe some other character, I am not doing that. But anyways, so in other case we can only have a closing bracket. So for the closing bracket we just have to check if the stack is empty. That means for the corresponding closing bracket there was never any opening bracket. So since there is no start, there being an end to the bracket is a bit weird. So in that case we will just return not handle. Or otherwise, if in the stack, let me show you the ASCII table. So in the ASCII table we can see that we have for the ASCII values of the round brackets, we can see that the closing bracket is the next one of the opening bracket in the round brackets. So it is just the next ASCII character. But for the square bracket and the curly bracket, it is 2 positions ahead. There is another ASCII character in between these. So what I did in this case is I just checked either the top can be a round closing bracket or a square or curly opening bracket, right? Closing bracket, I'm sorry. So if it is a round opening bracket, then we have to see if we have the corresponding closing bracket for it, the round closing bracket, which is 1 position behind in ASCII values. So what I did is first I checked for the round bracket if the top is equal to the current character -1, which in this case the current character is the round closing bracket. So if we have the opening bracket for it, then this condition can be true. Or the other condition that we can check is for the square and curly bracket. For both of these, the ASCII character is behind 2 positions. So if it is true, then in that case it is correct. So one of these conditions is becoming if either of these conditions become true, then it means that we have the corresponding closing bracket, and then the whole condition is going to become false, this whole condition. Otherwise, if both of these conditions are not true, that means we don't have the corresponding closing bracket, corresponding opening bracket for the closing bracket that we have. Then in that case this whole condition will become true, and we will go inside this if condition and return not balance. Otherwise, now we know that we have a corresponding opening bracket for the closing bracket. Then in that case we can just pop out of the stack, and after completing the for loop we can just check if the stack is empty or not, because if the stack is not empty, that means there are some opening brackets that are not being closed by their corresponding closing brackets. And in that case we can return not balanced, otherwise we just return balanced. So this is my solution for this. Let us ask ChatGPT as well if this solution is good enough or not. This might not be the best solution, and I will obviously not handle any error or edge cases for this. So let us just ask ChatGPT quickly. Okay, so basically ChatGPT told me that the way I'm handling ASCII values, this is more error prone apparently, and it is not safe in general C++ practice. So it is just telling me to like hard code this situation. Basically, for each bracket, just check if the top is its corresponding bracket or not. You can also do it that way. Nothing wrong with that. I think this question exists on lead code. Let me try and submit it. It is called valid parenthesis, I guess. Lead code. Okay, let us try submitting. It might fail depending on edge cases. Obviously, if they don't have any kind of edge cases, then it should work fine. We'll see accordingly if this works or not. Just a second. It should work. Okay, so this worked. Simple enough solution. The way I was doing it using ASCII characters also works fine, but since in general practice it is not good to do it this way, you can also avoid it. At least now we know what are the ASCII values of corresponding brackets. So we know that for normal round brackets, it is just one position after one another, and for the square and the curly braces, we know there are a difference of 2 positions in it. There is an extra character in between for both of them. So anyways, this solution worked. Now we can move on to the next question, which is this one. You can also try solving it with me if you want to. I will become quiet now. Okay guys, so we have solved this question as well. Uh, what we had to do in this question is that we were given a stack and we had to insert an element at the bottom of the stack instead of the top. So for this we could have used recursion. I use recursion for this. You can also you don't necessarily need to use recursion. You can also use an iterative approach. Just store the elements of the stack either in another stack, or you can also store it in a vector or whatever you want. I just did a recursive solution because it said so here. So what I am doing in this case, I think I should explain it to you using like a drawing or something. Just a second. So yeah, let me quickly explain it to you. So this is a very simple question. Let us assume in the beginning we had the stack 1, 2 and 3. So at the top we have 3, and what we want to do is we want to insert a new element 0 in the bottom. So what you can do for this is you can like one by one take these elements out, keep a track of them, and whenever the stack becomes empty you can just add this element 0 here, and then you can again start adding these elements in the same order back. So that way you will have it in the same order, so it will become 3, 2, 1, 0. Now how I am doing is I am using a recursive solution. So what I am doing is whenever the stack becomes empty, so if stack is empty, then in that case I just push the new element in the stack, right? And otherwise what I am doing is I am first keeping a track of whatever element is on top inside a variable top. So this will be the top of the stack, and then we pop this element from the stack, and then we do a recursive call on the stack, and in the recursive call we just pass the stack again along with the element. So now this stack has one less element. So for example, if we are starting out with 3, this top will contain 3. We pop out 3 from this, and so now the stack becomes 2 and 1. So that is what is basically happening, and once this recursive call returns, we will again add this top back in the stack, again push it back to the stack. So now the stack will become 3, 2, 1 and 0 like this. So let me show you the code. I don't think my explanation was that clear in this drawing. Hopefully you understood it, but anyways, so what I'm doing is this is my function. I am passing the stack to it and the element. I kept the return type void. You can, if you want, you can also, like, you don't necessarily have to keep the return type void. You can just return the new stack. Although I think this might be more memory efficient because you are manipulating the original stack. But anyways, so first is the base condition for recursion. You are going to be checking if the stack is empty or not. If it is empty, then you push the new element and then you just return directly from there. Otherwise, you first show whatever is the element on top is, then you pop that element out, and then you call this function again on the remaining stack. And once you return from this function call, you are going to push the top back to its position, to the top again, and that is how you do it. So this question is simple, very simple, unless you don't know what recursion is, although you can also use an iterative approach, I've already told you. But I think maybe I can also make a video on recursion problems to practice recursion and backtracking and stuff like that, so that can also be done. Anyways, for now we can move on to the next question, which is the fourth problem. You can also try solving it with me if you want to. I will mute myself now. So guys, I have solved the fourth question as well. It was quite simple. In this, we just had to display the stack without modifying it. What it means is that whenever we are printing out a stack, we are continuously popping from the top, so the stack becomes empty by the end. So this time what it wants us to do is print out all of the elements of the stack, but without emptying out the stack. So the stack should retain the original elements in the original order even after printing. So what I did for this is very simple. I just created another stack called rev. So this will be storing all of the elements of the current stack in reverse order. So what I'm doing is I am running a while loop until the current stack is empty, and I'm printing out the top. Then I'm pushing that top in this reverse stack, and then I'm popping from the original stack. So once the original stack becomes empty, the reverse stack has all of the elements in reverse order. So what you can do now is you can just continuously pop the elements from this reverse stack and just pop them in the original stack. That way you will be able to retain elements in the original order. So this is very simple. I have asked ChatGPT if there is a more efficient way. It just told me to use recursion, although it said this solution is good, but it said if I don't want to use an off and time complexity, I can just use recursion. So basically this similar code that I had for the previous problem, what you can do is you can just for this base case condition, you can just directly return, and after calling the function again, or before recursively calling the function or after calling the function recursively, you can just print out the top. So that way you can do it as well. I just did it like this. Anyways, that doesn't matter. By the way, if you are a beginner, these questions are very good for practicing, for you especially. So, and if you don't understand my solutions for any of the questions, then you can just go online, check out other people's solution. Completely understandable. I'm not good at explaining what I do. I just do it. So if you feel like my explanation is subpar or anything, you can just go online, check out anyone else's solution. Now let me also see if the third question exists on LeetCode or not. Well, it is not on LeetCode, but it is on Geeks for Geeks. If you want to submit it there, you can do it. I just have a habit of submitting my questions on LeetCode. But anyways, now after solving the fourth question, we can move on to some intermediate questions. Hopefully these are even better for practice. So I will become quiet now. I will mute myself. You should also try solving these with me if you want to. Okay, so I have solved this question as well. In this, we had to evaluate the postfix expression. So, if you don't know what a postfix is, basically the operator is written after the operands. So, I think you should go and check it out if you don't know what it is, what postfix expressions are. So, I hope you have checked it out. Now, I will tell my solution. What I'm doing is, if it is an integer, then I'm just doing character minus 0 to append that integer to the stack of integers. So this stack will only contain the integers, and whenever we hit any kind of operator, then we just pop two operands from it, the top two, and then we perform that operation on it, and then we append the result, or then we push the result, you can say. That is the way how we do it. For each of the characters it will be different, for each of the operators, you can say. So I don't think this is the most efficient solution in any way. Let us ask ChatGPT if our solution is good enough or not. It works, it gives correct answer, but let us see. Fifth problem. Okay, so basically, ChatGPT's what it says is, I should just assume I'm given a valid parenthesis or a valid postfix expression, you can say. So I won't need to use these if empty checks for those cases. I can just like directly write it like this. And another thing is, it just told me to like make sure how to solve it if there are white spaces. So I obviously did not do that in that case, because I wasn't going to be giving a white space in my input. So I ignored that edge case on purpose. But if you want, you can just solve it for that as well. You can use string stream for that, and then just pass it into a token and solve it like this. That is the way you do it. And anyways, let us see if this question exists on lead code or not. I mean, this is basically the same thing using stacks. Let me just put it here as well if it is not exactly needed like that. Okay. Okay, so the code worked. You can try submitting yours in this one as well. This is lead code problem 150. It is also called reverse Polish notation. So basically, the postfix evaluation, instead of inputting a string, they are inputting a vector of strings. Same thing, you can just modify the code accordingly and submit. It should work. Now we can move on to the next question. You can also try it out with me if you want to. I will mute myself now. Okay, guys, finally I have solved the sixth question as well. Just to let you know, this is a very specific kind of question. You won't be able to solve it unless you understand infix, postfix, and the conversion of one kind to another. So, for example, I knew what infix and postfix was, but since it's been a long time, I did it. I did the conversion from infix to postfix in 11th grade last 11th or 12th grade. I think it was 11th grade. So a long time ago. So I did not remember how to do it. So I had to search for it. How to convert infix to postfix. This is the Geeks for Geeks solution. Did not really help me much. I just watched an YouTube video. You can also check out any kind of YouTube video if you want to. I will also be explaining the code in a second. I'm just telling you in advance so that you don't get confused. So let me start by explaining the code to you quickly. So let us take an example of this test case. So just so you know, infix difference between infix and postfix. Yeah, so as you can see, infix is of the form A operator B. So basically, as you can see, A plus B, the way we normally write maths or algebra, whatever you want to call it. And postfix is A, B, and then the operator. So the operator comes after both of the operands that it is operating on. So that is how postfix works. That is the simplest explanation of infix and postfix. So now I will explain to you how to convert from infix to postfix. So this is an infix expression, this whole thing. And one thing to keep in mind in infix when converting from infix to postfix is the precedence of these characters or these operators, I should say. So each operator has a certain precedence with it. So some have a higher precedence. For example, this operator, this is the power operator, the cap you can call it. It has the highest precedence, and then the multiply operator and the divide operator, they both have the same precedence, and plus and minus operator, they both have the same precedence. Then anything else after these have the lowest precedence, although these are the main operators. So we will be assigning them some kind of value. For example, this since this operator has the highest precedence, we can assign it a value of 3, since this is the third highest. These two can be assigned a precedence value of 2, and plus and minus can be assigned a value of 1. So this is something to keep in mind when converting from infix to postfix. I will explain in a second how these will be used. So we have this stack, and we will be using this stack to only store the operators or the brackets, these two brackets. So in the precedence you can also add a bracket if you want to. So it can be like these two can have something like 0 or -1 if you want to. So we'll start. So any kind of operator we get, we push it to the stack, but we only push it to the stack if the current operator on top of the stack has a lower precedence than the one that we are about to push into the stack. If it does not have a lower precedence, then in that case we will be popping from the stack until we get to a character that has a lower precedence. So let me explain it to you using this test case. So the operator, first we get A, you can directly push it to the result A. Then you get an operator, which is, then you get this operator, which is the multiplication operator. You will push it to the stack. Then after this you get an opening bracket. Again you push it to the stack, we don't add it to the result. Then you get B, an operator, you push it to the result. Then after these we get another operator, which is the positive sign plus. So we will first check the precedence of the character underneath it. Since the precedence of actually from here, let us take out the opening bracket, because you don't want to be removing based on precedence when you hit an opening bracket. So you have this multiplication sign over here, and you check the opening bracket. Since we don't check for precedence in the opening bracket, you can just directly push it. Otherwise, when you get to an operator, for example plus, now we will check the element underneath. So in this case it is going to be this opening bracket. So since it is an opening bracket, we don't check for any kind of precedence or anything, and we can just directly push the sign. Actually, let me add the opening bracket here. It won't make a difference, because in the code we will just put a condition in a way that this won't make a difference. So this is the opening bracket, and once I have pushed the plus operator, we can move on to the next one, which is C. We can directly add it to the result. Now we hit a closing bracket. Whenever you hit a closing bracket, you will be popping from the stack and pushing it to the result until you hit the opening bracket right here. So what I'm going to do now is I will start popping from this stack until I hit the opening bracket. So first I will pop plus, add it to the result. Then I have it the opening bracket, I will just pop it out, and then I have to do nothing. Now the stack has become clear of this. Let me just delete these two. Now we don't have these two in the stack, and let me just cross out all that we have already dealt with. So then we can move on to the next one. The next character is the operator, which is the division operator. Now for the division operator, we will check if the character at the top of the stack, currently at the top of the stack, which is the multiplication operator, if it has a lower precedence or not. Since multiplication operator has the same precedence, we will be popping it from the stack and pushing it to the result. Now the stack has become empty, so we don't have to worry about anything. We can just push the division operator on top of the stack, and now we can finally move on to the last character, which is D. Now since again this is an operand, we can just directly push it to the result. Now once we have checked all of the characters in the string, what we can do is we can finally pop everything from the stack. So pop everything from the stack, including division operator, and just push it to the result, and that is how you get your result from infix to postfix. So what do you have to keep in mind is, first of all is the precedence of the characters. Keep in mind of the precedence of the characters. The power or the cap operator has the highest precedence. Then we get to the multiplication and division operator. These two have the same precedence, and the positive and negative operator have same precedence, and everything after that can have a precedence lower than these. And then the next thing that you have to keep in mind is you only push the brackets and the operators in the stack, and in the stack you have to keep in mind if you hit a bracket, an opening bracket, you just directly push it to the stack, and if you hit a closing bracket, you pop from the stack and add it to the result until you hit the opening bracket. And if it is just an operator and the top of the stack is not a bracket, then in that case you are going to be checking for the precedence. If the precedence is lower on top of the stack than the current character that we have, in that case you can just directly push to the top of the stack. Otherwise you will be popping from the stack and adding to the result until the top of the stack has a lower precedence than the current character that we have. So that is the way you solve this question. Let me show you the code now. So this is my code for this. First I'm taking the input of the string, then I have the result string ready, in which I'm going to be adding the postfix expression. You can also call it postfix if you want to. Then I have this stack st. This stack will be used to push the operators and the brackets inside of it. Then I created this unordered map. You can also create a function if you want to. I just created a map. It is simpler for me this way. So what I did in this is for each of the character I just assigned a value to it. So the cap has the value 3, multiplication division operator has a value of 2, and positive negative operator has a value of 1, and a closing bracket has a value of -1. You can also put in an opening bracket in this. So then you iterate the string, and first of all you check if it is an alphanumeric character or not. If it is an alphanumeric character, you directly push it to the result and move on. Otherwise you check if it is an opening bracket. If it is an opening bracket, then you directly push to the top of the stack. You don't have to check for precedence or anything like that. Otherwise you check if the character is a closing bracket or not. If it's a closing bracket, you pop from the stack until you hit the opening bracket. So once you have hit the opening bracket, you can stop popping and adding to the result. Otherwise you just check if it is an operator. Now you know it is an operator because the kind of input we are taking. I am not checking any error handling in this case. You can do it if you want to. Just don't check for white spaces or if it is not an operator. So I have not done that. I won't be supplying an input which is not which does not contain any kind of white spaces. I will only be supplying an input that does not contain any kind of white spaces. So then you, in the end, you know that it is going to be an operator. So now we will just run a while loop and keep checking until the precedence of the character on the top of the stack does not become lower than the character that we currently have. Until then you just pop from the stack and add it to the result. Finally you can just push your character to the top of the stack, and once you have iterated the whole string, checked everything, you can just run another while loop until the stack is empty and keep adding it to the result. That is the way you get the final answer. In this you can also add the opening bracket. Let me do that quickly. So this is the opening bracket. So this code works completely fine. I've checked it. Let me pass it to ChatGPT and see what it thinks of this code, to see if there is a better solution than what I am doing right now. Okay, so ChatGPT told me about precedence in this case. So my solution was mostly correct previously, but I was not keeping in mind associativity, which is left associativity and right associativity. If you don't know what it is, you can just check it out from somewhere else. Although everything that I've been searching is already in the video from ChatGPT, so you can just check it out from here as well. I can just explain it to you like this. So a negative sign is left associative, as in you will be, for example, if there are two negative signs one after another, so you will be solving the left one first, and then you will be solving it with the right one. But with this power operator, or you can call it the cap, whatever you want, XOR operator, it is right associative, so you have to keep in mind of that. So in this case, if you have two of these XOR operators one after another, you will be solving the right one first and then the left one. That is how it works. So you have to keep that in mind, and because of that, once you hit right associativity, you should not just directly you should not be popping from the stack based on the equal precedence. Instead of that, you should just be pushing inside of it. So that is all that was different. You just have to keep in mind about associativity, left associativity, or right associativity. And right associativity is only with this XOR operator, otherwise everything is left associative, so you don't have to worry about that. And this is it for this solution. Keep in mind this associativity. So basically you just have to check, first of all you check if the precedence is greater, then obviously you're going to be popping. But if the precedence is equal, then it can be a case of the XOR operator. So if it is a XOR operator, then you return false and you don't go in the while loop, you don't pop from the stack. Instead of it, you only push. Otherwise, if it is not a XOR operator, then as we know, you just continuously pop from the stack and then append to it. So keep in mind of this. So what you have to keep in mind for this question is the precedence of the characters accordingly. You have to keep in mind that if you hit brackets, then whenever you hit a closing bracket, you pop from the stack until you hit an opening bracket. And otherwise, when pushing to the stack, you just have to keep a check of precedence. And if it is a higher precedence, you just obviously pop until you hit a character with a lower precedence. Otherwise, if the precedence is equal, it can be a case of the XOR operator. So if it is a XOR operator, you don't pop, you just push into the stack. Otherwise, if it is not a XOR operator, you pop from the stack until you hit a character that has lower precedence, or until the stack is not empty, and then you push to it accordingly. So keep this in mind, the left associativity and right associativity accordingly. If this question confused you, you can just go out and check someone else's video online. I will be honest, this is a bit confusing and this is very specific. You need to know how to convert infix to postfix specifically, these conditions specifically. So it is quite a bit specific, you have to be careful of that. Other than that, you are good if you understood it. Hopefully you tried it yourself as well. Let us see if this question exists on LeetCode or not. Okay, so I checked and I could not find this question on LeetCode specifically. So if you can find it, just link it in the comment section below. For now, I will just be moving on to the next question. You can also try it out with me if you want to. I will mute myself now. By the way, I think before solving the 7th question, let me explain to you why associativity works the way it does clearly. So it will take just a second. Let us take the examples that ChatGPT had given us. So just a second, I hope my screen is visible. So let me clear out the whole screen first. So first of all, let us take the example of right associativity, or actually the left one. So we have A minus B minus C, you have left associativity. Let us create the result over here, and the stack. This is the stack, right? So first you will go to A, you will be adding A to the result, then you will hit the minus sign, minus operator, then you will be adding it to the stack. After this you will hit B, you will be adding B to the result, then again minus operator. Once you have hit the other minus operator, you can see that there is already a negative operator in here, same precedence, and it is left associative. So we are going to be popping from here and adding it to the result. Now the stack has become empty, so we can add the new negative operator to this. Then we will finally hit C, and we will pop from the stack until it is empty. So this is the result that we will get. Now in this result, if you are moving from left to right, what will happen is first you will be solving these two characters together, a b minus, because postfix expressions are of a, b, and then the operator, right? So this is postfix expression. So first you will be solving a, b minus. You can't solve c minus because there is no operator along with c, so that would not work anyway. So a, b minus, which will be a minus b, and then we will get one whole value of this, which can be an integer. So let us take an example like 1, 2, and 3, or make it easier for ourselves, 5, 4, and 3, right? So let me take 5, 1, and 3. So first we are doing a minus b, which is 5 minus 1. This will be 5 minus 1, and this will be equals to 4. So we have 4 now. So what we have over here, what this whole expression is going to become is, we will have 4, and then we will have c, which is 3. So 4, 3, and minus. So this whole thing will be 4 minus 3, and we will get minus. We will get 1 as the answer. That is how we are solving it. Now let us check how it works for the power, or the XOR operator, we should call it the XOR operator, quickly. So now you have this XOR operator. What you are going to be doing, first you will be adding a to the result, then you will be seeing an operator, you will add it to the empty stack, then you have b added to the result, b, and then you again hit the XOR operator. Now these two have same precedence, and since it is right associative, we won't be popping from the stack. You again have the XOR operator in it, and then you get C, and then you pop from the stack until it is empty. So we will get these two XOR over here. So how this works is, since it is right associative, we want to solve B XOR C first, right? Or B power C, you can call it. So since we want to solve this first, we have to make sure these two are getting solved first. Only then we will be solving the result with A. That can only be done this way, since right now we don't have any operator right after A and B, or basically not in the format AB operator with A anywhere, so we won't be able to solve it first, but we have BC operator, so we will be able to solve this first. So let us take an example, 1, 2, and 3, simplest example. So first we will be doing 2 to the power 3, which is 8. Right, we get 8 now. So this whole thing has become 8. B to the power C has become 8. Now we have A, which is 1. We have 1. We have 8. And we have another XOR operator. So now again this is in the format AB operator. So we will be able to solve it. Now 1 to the power 8 is obviously going to be 1 still. Pardon my writing, I am writing using a mouse. So 1 to the power 8 is still 1. Or you can also do like 2 to the power 8, which is 256. So let me just do 2 to the power 8 quickly. You have 2 here, so 2 to the power 8 is going to be 256. And that is the way you solve this. So now we know that with right associativity, the elements in the left can't be solved first. So since we are not popping from the stack, we are removing that possibility of solving the left ones first. And when we have the character with left associativity, we are popping from the stack so that the characters in the left are being solved first, right? So that is how it works. Hopefully I was able to explain it decent enough. I don't know if I was able to. If you don't understand it, still you can go online, check other sources online. The only thing you have to keep in mind is you solve characters with higher precedence first, and then you solve characters with lower precedence. And other than that, if you have to keep a check of associativity. So if it is left associative, you solve from the left, and if it is right associative, you solve from the right. That is the only difference in this. So now we can move on to the next question, which is the 7th one. You can also try solving it along with me if you want to. I will mute myself now. Okay, so I have solved this question as well. This turned out to be simpler than I expected, honestly. So I will explain it in a second. Actually, let me explain it first. Yeah. So I hope my screen is visible. So let us take two stacks. The first is stack 1. This is the original stack, stack 1. And let us take a stack 2. This is the one that we'll be using for sorting. The final output in this case will be stored in stack 2, or if you don't want it that way, you can also do it with stack 1, doesn't matter, but as you wish. So let us take a variable called top. This will contain the top of the first stack, right? So let me take the simplest in test case, in this case 3, 5, 2, 1 and 4. So I want to, right now let us say I want to sort it in descending order. So for example, in stack 2 I want it like 5, 4, 3, 2, 1, with 1 being at the very top. So if you print it, it will be in ascending order, but in the stack the elements are in descending order. So let's do it this way, in descending order. So how you do it is, you check the first of all the top element in stack 1, which in this case is 4. Then you check if the stack 2 is empty or not. If it is empty, then obviously we are going to be pushing it in stack 2. Let me create 5 spaces for it quickly. Yeah. So if stack 2 is empty, we directly push it, completely fine, and we pop it from the first stack. So let me just quickly pop it. We have popped it from the first stack, we pushed it to the second stack. Now the second element 1. Now the top of stack 1 is 1. Now what we are going to do, since we are going in ascending order, we know that the element below, or the element currently at the top of the stack, should be greater than the element that we currently have, right? So for example, if you have A and B in stack, you know that A should be greater than B or greater than equal to B. So we know that it should be greater than equal to B. So you are just going to be checking if the topmost element in the stack is greater than the top of stack 1 or not. Since it is greater, 4, so we are going to be adding it 1, and we will pop it out from stack 1. Then we will check the next top of stack 1, which is 2. Now again we will check the same condition. If the element at the top of the stack currently, stack 2, is greater than top of stack 1 or not. Since it is not greater than equal to, it is less than the current element. So what we are going to do is, we are going to pop from stack 1 and we will push it back to we are going to pop from stack 2 and we will push it back to stack 1, right? So what I'm going to do is, I'm going to pop this one from stack 2 and I'm going to push it back to stack 1. So again we check if stack 2, the topmost element of stack 2 is greater than the top of stack 1 or not. Since it is not, we can just directly append 2, and now this top has become empty. Now we will check the top of stack 1 again. It is 1, so it is 1. Now we will check for stack 2. Since the top of stack 2 being 2 greater than 1, we will just push this top in stack 2, which is 1. Now again we will check for the next element, which is 5. Since 5 is greater than 1, which is topmost of stack 2, we are going to be popping from stack 2 like this, and we are going to be pushing to stack 1. Again 2 is less than 5, we will pop from stack 2, we will push to stack 1. Again 4 is less than 5, we will pop from stack 2 and push to stack 1. And then we will push this 5 Now, as you can see, these three elements that we have popped from stack 2 and pushed in stack 1, they are in sorted order themselves, right? So all of the operations that have already happened, they technically won't be happening again. You just popped from this stack in order, and then you just push them back to this stack. Simple as that. So now we will do the same operation again. We will pop from the top of first stack. It is 4. 4 is less than 5. We will be pushing it over here, right? And then again we will check the next element. It is 2, so the top is 2 now. It is less than 4. We can just directly push it. Now we will check the next element. It is 1. 1 being less than 2, again we can just directly push it to the stack 2. Now we can check the next element, which in this case is 3. Now since 3 is greater than 1, we are going to be popping 1 from stack 2, and we are going to be pushing it to stack 1. Again 2 is the top of stack 2 now. 2 is less than 3, so we are again going to be popping from stack 2, and we are going to be pushing to stack 1. As you can see, they are being pushed in the sorted order. And then you will check the next top of stack 2. Since it is 4, it is greater than 3, you don't have to worry about anything. You can just directly push 3. Now we can start popping from stack 1 again. Since it is 2 and 2 is less than 3, you will just directly push 2. The next element is going to be 1, and since 1 is less than 2, you can just push 1 here. Now we have all of these elements in sorted order, and the time complexity, I think in this case, is going to be of n square, because for each of the element you can push and pop it from both of the stack about n times, so it will become O of n square. I think so. This is the solution to sort a stack using another stack. Let me show you the code as well now. So the code is very simple. I'm running a while loop till the first stack is empty, as we saw in the test case as well. When the first stack becomes empty, we can see that the second stack becomes sorted in either of the order, so depending on how you want to sort it. So we have, first we are going to be taking the top of the first stack, pop it from the first stack. Now if the second stack is empty, you can just directly push it to the second stack. Otherwise you will check if the top of the second stack is greater than this current top or not, the top of the first stack. If it is greater, then you will just directly push it. Otherwise, if it is not greater than the current top, you will just pop the top of the stack 2 and push it to stack 1, and pop it from stack 2 obviously. So very simple solution. I think this works. Let me ask chat GPT if this works or not. Let me ask. This is problem 7, right? There could be a better solution for this, I am not sure though. Hopefully this works. Okay, so it said that my solution is clear and good. It has also told me if since in this case I was only allowed to use one extra stack, so I solved it this way, but there can be a possibility when you are told to sort it without using an extra stack. So ChatGPT is telling us that it will be a recursive solution in that case. Right now I'm not solving it because I want to practice stacks exactly. So I think since it is more that approach will be more about recursion, we can do this later when I practice recursion in any way. You can try solving it right now if you want to. For me, I'm just going to move on to the next problem. You can also try solving it with me if you want to. I will mute myself now. Okay guys, so I have solved the next problem as well, which was the next greater element. First I did not know what the next greater element was. I mean, I did not understand what ChatGPT was trying to say, so I asked it and it told me just whatever is the next great element which is greater than the current element. So to the right is going to be the next greater element of the current element, and so we just output that in place of the current element, basically you can say, store that in the result. So let me explain to you first what I did for this. So let me explain the code first quickly. I have taken an input in a vector of size n, and after that I created a stack and a result vector as well. In the result vector I just initialized it with -1, not necessary, but you can do it if you want to. So what I'm doing is I'm iterating in reverse order, and I'm keeping a track of the current greatest element. So what I'm doing is I take the current element and I pop from the stack until I reach an element that is greater than the current element, until the top of the stack is greater than the current element. Once we have hit that, then we know that we what is the rightmost greater character of the current element, and we just replace it in the same index in result as the index of the element in the vector. So otherwise you just add -1 if the stack is empty, because if the stack is empty then you don't have any element greater than the current element in the right. And after that you just push the current element to the stack. That is the way you solve it. So let me explain it to you a little bit better using paint. So I hope my screen is visible. Yeah, so let me take an input vector. Let us call this input vector this, and let me take the test case like 4, 5, 2 and 25. Let me take the result vector right over here, result, and let me take the stack st. So I am iterating in reverse order, right? So first I'm going to be checking with 25. So now since the stack is currently empty, so there is no element to the right of 25 that is greater than 25. So we will just add -1 in that case, right? And then we move on to the next element, which is 2. Now we have 25 in the stack by now. So you update the result with -1 and push 25 to the stack. Then you move one element ahead, which is 2, backwards. So now with 2 you are going to be checking if the top of the stack is greater than 2 or not. Since it is 25, it is greater than 2. So we will just be adding the top of this stack to the result, which is 25, which is the next element after 2, which is greater than 2, or next greater element of 2 you can call it. So now we can push this 2 to the stack as well. Next we move on to 5. Now with 5 we can see that 2 is not greater than 5. So we are going to be popping 2 out of this stack. So let me do that quickly. I have popped 2 out of the stack, and then the next element is 25, which is the top of the stack. Since it is greater than 5, we will just add it over here, 25, and then we will push the current element, which is 5, to the stack as well. Now we move on to the next element, which is 4. Now with 4 we are going to be checking the top of the stack. Since it is 5 and since 5 is greater than 4, we are going to be adding this result to the top, this top to the result, which is 5, and that is how we do it. So what we are basically considering in this is, for example, let me take 3 elements, A, B and C. So let us assume that A is greater than both B and C, right? So once we have hit A, right? So once we know that A is greater than both B and C, so A is the current greatest element. So for example, if we take an element D, and if we look to the right of D, the next greatest element for D is going to be A itself. It can never be B or C, because B or C are already smaller than A. So in that case, we don't need these B or C anymore. We can just completely discard of these. So that is exactly what we are doing in this. Since these elements can never be the next greater element, or for this element D, we don't need them at all. So we will start with A, and whatever else is left here, for example E, if E is greater than both B and C as well, will be left here as well. So that is the way you do it. And since we are moving in reverse order, the top is always going to be the next rightmost element of the current element, which can be greater than the current element or less than the current element. This is how you solve it. You can also try it out with the other test case as well if you want to. I won't right now. You can do it if you want to. So let me explain the solution to you again. I have this stack which is going to be keeping a track of all of these elements to the right, and I have this result array that I have created, or result vector, in which I'm going to be adding the result. I iterate backwards or in reverse, and I just check if the current top of the stack is greater than the current element or not, or if the stack is empty or not, and then I pop accordingly. And if the stack is not empty, I just update the result with the top of the stack. Otherwise, I just push the current element, and at the end I can just print the result out. If you don't initialize it with -1, you can just check if the stack is empty or not. If it is not empty, then you are adding the current top of the stack. Otherwise, you can just add -1. So that is it. Now we have solved eighth question as well. Now we can move on to the ninth one. You can also try solving it with me if you want to. I will mute myself now. Okay, so we have solved the ninth problem as well. It is very simple, the simplest one among these intermediate questions, I will say. A bit too simple. So in this we just had to remove consecutive characters or the consecutive duplicate characters, and for this we had to use a stack. We can obviously do it without a stack. We can just check what is the previous element or what has been the previous character and then do it accordingly. But since we had to use a stack, what I did is, if the stack is empty, in that case I will just push the current character to the stack, which is obviously going to be the first character of the string, and then I will update the result and continue. Otherwise, if the top of the stack is equal to the current character, which means it is a consecutive duplicate, then in that case I am going to be continuing. Otherwise I will be pushing to the top of the stack, because it means we have hit a new and unique character, basically not a consecutive duplicate. In that case we are going to be pushing to the top of the stack and updating the result, and then we can just print the result out. Very simple solution, we don't have to think too hard about it. Now we finally move on to the advanced questions. These are going to be a bit difficult, I guess, so you should be ready to try them out as well. Try them out yourself, they will be difficult. If you have any difficulty in understanding, then you can just check for solutions online as well. I would assume most of these problems are going to be existing on lead code and stuff. Most of these, not all obviously. So yeah, I will mute myself now. We can start with the 10th problem, which is supposed to be an advanced problem for stack. You can also try solving it along with me. Okay guys, so I have solved problem number 10th as well. So there was a massive flow in the way the chat GPT like framed the question or worded it, you can kind of say, because what ChatGPT told us is we just, for each day we just had to calculate how many days before the current day have a price less than the current price or equal to today's price. So that basically I had been thinking for about like half an hour or an hour for a solution using stacks on this that would have been efficient enough. You might not have seen it because I would have cut that part out of the video because I was not doing anything, but anyways, so that was not making any sense to me. So I started looking online for solutions of this problem, and then I found out that ChatGPT phrased it or worded it incorrectly. So I asked it again to explain the problem to me, and it did exactly that. This time it explained it correctly. So instead of just calculating all the number of days before the current days that have been less than the price of the current day, less than equal to the price of the current day, we have to find the number of consecutive days before the current day that have a price less than today. That is what we were supposed to do instead of just every single day before the current day that could have had a price less than the price we had today. So that made the problem very difficult, and I was unable to use it, unable to implement it using stacks. At least I was unable to think up of a solution. So after searching online and looking at other people's solution, I finally did it. You can also look online for its solution. Obviously, if I understood the problem correctly from the beginning, I would have been able to figure out the solution myself in like 10 minutes or so. But because the problem itself is not that difficult, it is basically the same as other problems that we have solved so far. So I think first I should explain the code, then I will explain it to you using a test case in Windows Paint. So what I did is, first obviously I took the input of the vectors, and then I created a stack and a result vector. So what I'm doing in this is uh, I am basically storing the elements in the stack in descending order. So if for example I hit an element or the current price which is greater than the top of the stack, so it breaks the descending element condition and it has suddenly become ascending. So I am going to be popping until I hit the next greatest element, basically the previous greatest element, the previous greater element, you can kind of call it, from the current element. And after hitting that, I will just calculate how many days were in between, uh, how many consecutive days were in between, because it will be consecutive that way, and then I will be adding it to the result, to that index of the result. Obviously I got this condition right from the first get-go because I had already seen someone else's solution. So the only thing in this is, if the stack is not empty, then we just do I minus top of stack, which basically gives us all of the days in between, including the current day. And otherwise we just do I plus 1, basically, since the stack is empty, so we know all of the days before the current day are less than the current day. So we can just do I of plus 1 directly and just put it in the result, and then we can push the current index in the stack. Previously I was going to use a pair, so I was going to be appending both just the index and the value itself, but you can avoid that by just putting in the index. Now I think I should explain the solution to you using Paint or something, so let me quickly do that. I hope my screen is visible. So let us take the base case, test case, you can say 100, 80, 60, 70, 60, 75 and then 85. Actually, I think I can find this base test case for it online. Let me just check quickly. So I was able to find this image using Geeks for Geeks. So let me just put everything here instead of this. So first we have 100, then we have 80, then we have 60. Oh wait, this is the wrong one. Just a second. So I was unable to find one online, so I created this myself quickly. So let me create the stack first. The stack will be this, ST, you can call it. So what we can do for this is, obviously when we reach the first one, as I was saying, I am putting them in descending order, right? So when we reach the first one, we know that the stack is empty, so we can just update the result for it. Oh, let me put the result close to this. We put a line above so that it's a bit more clear. So the result for this will be, first will be 100, and we will be pushing 100 to the stack, right? So then we have 80. We will check top of the stack. Since the top of the stack is 100, which is greater than 80, we will just directly push 80 over here, and we can update it to 1, since there is no day before the current day which is less than equal to the current day, but the current day is still there, so it is going to be 1. Just so you know, we are also counting the current day in it. Next we will get to 60. Again, 60 is less than 80, so we'll push it to the stack. We will update the answer to 1. Then we move on to 70. Now we can see that 60 is less than 70, right? So we will pop 60 out of it, and we will push in 70. Now we are counting 2 elements in it, since it is the current day as well and the day before it, which is less than the current day, and there is only one, which is 60, and it has to be consecutive. So even if we had something after 80, for example, we have a 65 here, that won't be counted because we have 80 in between, and it is not going anywhere, so we would not have put that 65 in there. So now we have 2 elements, which is 70 and 60. We are going to be updating it to 2, right? Then we again have 60. Since just a second, since 60 is less than 70 anyways, so we will just directly push 60 in it, and we will update this to 1, since there is no element before it which is less than equal to the current price or today's price. Then we have 75. Now 60 is less than 75. Let me just show it to you a bit more clearly. Let me remove this previous 60 so that it becomes a bit more clear to you. Okay, we have 70, then we have 60. Now we have 75. So what we can see is 60 is smaller than 75, and again 70 is smaller than 75 as well, and we also have this 60 which is smaller than 75, right? So but as you can see, that 60 is not in there because we have already eliminated it. Why did we do that? Is because once we have appended this 70 in there, we know that any element which is less than this 70 towards his left is always going to be smaller than an element which is greater than 70. So if there is any element, for example 75 or 85, 70 is already smaller than these two, right? So any element which was smaller than 70 is also going to be smaller than these two. So what you can do is You can also use a dynamic programming approach in this. You can take the index of this 70 and you can take the answer from that 70, which is 2 in this case, and you can add it to your current solution. For example, you already have 75, 60, 70 already removed, right? So you can have this answer of 70, which is 2 minus 1, and add it to your current answer, which is going to be 3 in this case. So we will have 3 plus 2 minus 1, so this will become 4, right? So you can use a dynamic programming approach, although I did not in this case. Other thing that you can do for this is you can use the indexes. Since we know the index of 80, which is the next element after 75, which is greater than 75, you can just use that index and calculate how many elements are in between. So you have this previous index and you have index for this 75. Now you can directly subtract index of this 80 from 75 to get the elements in between, along with this 75 included, right? It is basic maths. You should be able to find it, and that way we can get to the current answer, which is going to be 4. Since 75 minus 80 we are going to be doing, this is index, let me update, 1 2 3 4 5 and 6, right? So index of 75 is 5, and index of 80, which is the next greatest element or the previous greater element of 75. So if you subtract these two, it is going to be 4. 5 minus 1 is 4, so you are going to update the result to 4, and we will update the stack as well accordingly. We are going to be adding 75 in the stack. 60 and 70 have already been removed, so there we have it. Next we have 85. We know 75 is less than 85, you remove it. You know 80 is less than 85, so you remove it as well. You add 85, and now we can see that 100 is greater than 85, so we can't remove it, but we know the index of 100 and we know the index of 85. So what you can do for this is you can directly you can calculate using indexes. So we have this 100 and we have this 85. Take the difference of these two, so we will get 6 minus 0. So there are a total of 6 elements that are greater than the current less than equal to the current element. This 100 is not counted. We have 80, 60, 70, 60, 75 and 85, which is the current day's price as well. So we will be including the current day as well. So this will be 6 over here, and this is the way we solve it. The solution itself is quite simple once the question is clear enough. ChatGPT made a mistake there, so it made me confused with the solution and the question as well. If you have any other approach in your mind, you can also try it out. I can show you the solution again, the code again. So I've already explained it to you. I have a stack, I have a result vector, I'm storing in descending order in the stack. If that condition gets violated, until that condition gets violated by the current element, we pop from the stack, and after that there's the condition that if it's getting violated, we pop from the stack continuously. And once we can see that if the stack is empty, then we can just update it with I plus 1, because as we know, all of the elements before it are already less than the current element. So you can just do an I plus 1, and if the stack is not empty, we can just simply do I minus the top of the stack, and the top of the stack is the index of the previous greater element of the current element. And then you just push the current element to the stack, because as we know, going ahead, there is currently, until the current element, there is currently no element consecutively before the current element which is smaller than the current element. So you will be pushing the current element in it as well, and that is how you solve it. Now I just can't trust ChatGPT enough with these problems, because it gave me wrong one. Even for this next one that you can try out with me, which is the 11th problem. It is quite popular one, I guess. If this solution is not making sense to you, you can directly search for the problem online, or just ask ChatGPT or any other way you want to find out what the correct problem is supposed to be, understand it correctly. You can also look up solutions online if you want to. These are advanced questions, although they are quite easy. If you have solved the previous problems, all of them, by now they should be easy enough. But uh, you can just check for solutions online. And yeah, now we can just move on to the next one. You can also try it out with me if you want to. If the solution is not clear enough, I will just search for it in this window itself, or I will ask ChatGPT itself. So you can also keep looking at this if you want to, or update it yourself, because I will be going on my pace, obviously. So if you want to check it out by yourself, you can do that. I will mute myself now. You can also try solving this question with me if you want. Okay guys, so finally I have solved this question as well. This has been the most challenging question uh, of this whole question set of stacks, I can say. In fact, it was quite difficult. It took me a lot of time to figure out the correct solution for it. Initially, my initial solution that I thought of this question was quite similar, but I did not implement it because I kind of wanted to do it in one loop. So I just wanted to be able to figure out a solution that can be possible in one loop, but I was not able to figure it out. As I have previously done a question of trapping rainwater, you might have seen it. So in it I have used a technique of prefix and postfix to solve the question. So that kind of stuck with me, and when I saw this question I knew that it can be solved like that, using prefix and postfix approach kind of for stacks. So that is the approach that I have used here as well. Previously I was making a mistake, is that let me show it to you. I was making a mistake, is that I was not accounting for this empty part right here. So that was the mistake I was making, and it was obviously because I was only trying to use one loop. I think I'm not smart enough to be able to do that right now, but this solution works. So what I'm doing for this is, we have already solved a question of greater element, which checks the previous greater element that we could have had. So it is quite similar to that, not that exactly though. I think first I will be explaining the code to you. So after taking the input, I create the stack. This stack will be containing the elements in monotonically increasing order. So that's a condition that we have to remember. And then I create two vectors. One is the prefix and the other is the postfix. I've called them left and right in this case. So left is the prefix and right is going to be the postfix, you can say. Let's just call them left and right for now. So what left is going to do is, for each element, let me show you. For each element, the vector left is going to be containing the index of the element that it can reach on the left at max. So basically, for example, we have 2 over here. Since there is no element before 2 that is greater than equal to 2, so 2 cannot move backwards. Its area cannot go backwards. So it will be -1 in this case, because we can't move backwards. Similarly, when we move on to 1, we can see that there is an element before 1 consecutively that is greater than equal to this current one. So we can store the index of that element, which is going to be 0 in this case. Then we move on to 5. Now 5, as we can see, 5 does not have any element before it, which consecutively before it, which is greater than equal to 5. So in that case, we are going to be storing -1 here. Similarly with 6, we do not have any element before it which is greater than equal to 6. So we are going to be storing -1, because we cannot have an area of 6 towards the left now, because there is no element greater than equal to 6 right before it. So the area of 6 cannot go towards left. And then we reach 2. We can see that 6 which is right before 2 is greater than equal to 2. Then we again have 5 which is greater than equal to 2. But then we hit 1. Now 1 is not greater than 2, it is less than 2. So in 2 we are going to be storing the index of 5, which is going to be 2. Index of 5 is 2. And then we move on to the last element, 3. Since there is no element before 3 which is greater than equal to 3, the area of 3 cannot extend towards the left, so we can't have anything there. So we will be putting -1 again. Then we can do the same thing for right. The code is exactly same. We are just iterating from the right. We are iterating backwards in the array. So let us see how that works. So we iterate backwards. First we have 3. So since there is no element to the right of 3, since we are iterating backwards now, we are going to be checking if the area can extend towards the right or not. So to do that, we will be starting with 3, since there is no element to the right of 3 which is greater than equal to 3. So the area of 3 can't extend towards the right. We will be putting -1 in this case. Then we move on to 2. As we can see, 2 can extend backwards towards 3, that is. So the area of 2 is going to be, in 2 we are going to be inserting the index of element 3, which is 5. As you can see, 5. And then we move on to 6. Since 6 does not have any element towards right of it which is greater than equal to 6, we are going to be putting -1 in this. As you can see, -1 right here. So then we move on to 5. There is an element to the right of 5 which is 6, which is greater than equal to 5, but 5 is not greater than equal to 2, so we are going to be ignoring 2, and we are going to be inserting the index of this 6. Now the index of this 6 is 3, so we will be putting 3 in that case. Now we move on to 1. Now this 1 right here, it can extend towards 5, 6, 2 and 3, so it can extend towards the very back, so we will be putting the index of 3 over here, which is 5 in this case again. Then we move on to 2, and since 2 cannot extend backwards or forward, you can say, we will be putting -1 in this case. Then once we are done with all of that, what we can do is we can iterate again from 0 to n, and we can calculate the left area and the right area. So basically, for example, for this 6 we can calculate the area on its left, and we can calculate the area on its right separately using the indexes that we have stored in the left and right array. And we can calculate the area which is taken by this 6 itself, as well as the current area. You can call it the current area, and then you can take a sum of all these areas to find the area that this element can contain. And then we can use a max variable for each element. You can just keep checking whichever is greater, you use that one. So now I think I should explain this to you using stacks, because since we are using stack, I just kind of verbally explained it to you, the logic kind of half-assly. So let me explain it to you using stacks quickly. So I hope my screen is visible to you. So before explaining the code, I will be explaining the solution to you using Paint again, obviously. So let me explain it to you quickly. I think since both the left iteration and right iteration is same, I won't be covering the left iteration right now, because the right iteration and left iteration is same, and using the right one I will be able to explain to you another condition which I am using in my code, which is required. So I will be starting with the right iteration, or the right vector, you can kind of call it. So I have right over here first. Let me create the stack, which is st. So we will be moving on from the right. We have element 3. We have this element 3, since the stack is empty right now and there is no element towards the right of 3, we will be putting -1 in the vector right. Then we move on to 2. Now since the stack needs to be increasing, it should be monotonically increasing. So when we try to put 2 here, we can see that condition is being violated, because it should be monotonically increasing and there is 3 over here, so it will be decreasing. So we will be popping 3 from here, and the index of this 3 that we have popped is going to be stored in the variable top, right? So this variable top is going to be storing the index of this 3, which is going to be 5 in this case, 5 index of 3. So we will be putting now, since the condition of stack is not being violated, we will stop popping from the stack, and we will be putting this top right here. Now with this top, what we are going to be checking is, first we will have to check if the element at this index has a -1 or not, because if it does not have a -1, which means that element itself can also extend backwards, and since it is able to extend backwards, the current element should also be able to extend backwards, because this element at 5 should be greater than equal to the current element anyways, right? So when we want to move on to to the right, the element to the right should be greater than or equal to the current element, in this case which is 3. So the element to the right of 2 is 3, which is greater than or equal to the current element, so we are able to extend it. So if that element itself that we are extending to, if that element itself can also extend backwards, then the current element can also extend as far backwards as that element can extend. So we are going to be checking the index stored at that position as well. If it is -1, we will just directly put 5 here, which is the top itself. We will just directly put the top in that case. Otherwise, if it is not, whatever index is going to be here, we will be putting that in this place. I will explain it to you clearly in a second. One of these elements has that exact condition, so let me show it to you in just a second. So we will be storing 5 in this case. Now let me show you by the code. Actually, let me just copy that condition quickly and paste it here, condition that I am using, so that it becomes more clear to you. So this is the condition that I am talking about. I am using it for both left and right, but right now I am only showing it for right, so that doesn't matter much. This condition right here, let me increase the size of this quickly. This is the code. Anyways, so now we store 2 in this case. We have stored 2. Now after 2 we move on to 6. Since 6 is greater than 2, the condition is not being violated, it is still monotonically increasing. We will just push it to the stack, and since top is going to be -1 by default, the way we have defined it, and there is no element to the right of 6 which is greater than or equal to 6, so 6 cannot extend backwards or towards the right, you can say. So we will be putting -1 in this case. Then we move on to 5. Now since 5 is less than 6, the condition of monotonically increasing is being violated, so you will be popping 6 from here. Once you pop 6, you will be checking. Once you pop 6, you will be storing the index of 6 in top. So index of 6 in this case is 5, 4, 3. Index of 6 is 3, so we will be putting 3 in this case. Then we will be checking if the value at this index 3, which is this value, if this value itself is not -1, then we will be putting, if it is not -1, then we will be putting this value in its place as well. Otherwise we will be putting the top that we currently have. So the top that we currently have is 3, and the previous one was -1, so we will be putting 3 over here, and we will be pushing 5 to the stack. Then we will check with 1. Now with 1, condition is being violated by 5, condition is being violated by 2 when we put 1 in this case. So since the condition was being violated by 2 and the index of this 2 was 5, 4, the index of this 2 was 4, right? Now this is where the condition that I was talking about is being applied. So we have top 4. So if you check with 1, you can extend to 5, you can extend to 6, you can extend to 2 as well, which is 4. But we can clearly see that we can extend further ahead towards the right with 3, because 1 is still smaller than that element. And so what this tells us is, if the element that we are checking, the index that we have checked of the greater element for the current element towards the right, if that greater element is able to extend backwards, so if that greater element also has a greater element of itself, then that greater element is going to be the greater element of the current element. So what we can say is, we will be checking this condition. We will be checking right of top, which is right of top is going to be right of 4, and in the index 4 we have 5. Since 5 is not equal to -1, we are going to be putting this 5 over here, right? because we can extend this one till 5 as well. We cannot only extend it till 4, we can extend it till 5. So we will be putting that in this place, which is 5. And similarly, then we will move on to the next element, which is 2. Since the condition is not violated, you will directly push it to the stack, and then since there is no element towards the right of 2 which is greater than equal to 2, we cannot extend it towards the right. We will just be putting -1 in this case. So that is the way you solve it. You follow the same step for the vector left. The only difference is that in this case, obviously, in this case you will be changing right to left because we are performing functions on the left vector. The only difference is that you are going to be iterating from the left, so from the beginning to the end, and that is the only difference. Now let me show you the code to explain everything more clearly to you. So in the code, first we have the stack that we are going to be using to store elements in monotonically increasing order. Then we create both the vectors, which is the left and right. The left is going to be storing for each element, the left is going to be storing the index of the element towards its left, till which we can extend the current element, right? So that is what we can do for this towards the left. And similarly for right, we will be checking for the element towards right of it consecutively, the last element greater than the current element. And then we start iterating. First I iterated for the left vector. So what we have over here is, first we define the variable top equal to -1, which is the default value, as we know, since if it is not able to extend towards the left, then we are going to be putting -1 in that case. So then you use a while loop to satisfy the condition of the stack monotonically increasing, and in the while loop, when you are popping from the stack, you are going to be putting the top equal to that top, since that top is going to be greater than the current element, and it is going to be till which the current element can extend towards the left. So then you push the current index to on top of the stack. Then we will be checking if top is -1 or not. If it is not -1, then we move inside of it and we put left of I equals to left of I will be put equal to left of top, or basically the index top, the value at index top in left. If it is not equal to -1, if it is equals to -1, then we will be directly putting it equal to top. Then after coming out of this loop, we will empty out the stack first, and then we will follow the same step for the right vector. After we are done with this, we will define a variable called max area. You can put the most minimum area possible for it, int min if you want to. Anyway, so then we will iterate from beginning till end. For each element we will be checking, we will be creating a variable area left and area right. We will be checking if left is not equal to -1, that means we are able to extend it towards the left. There is some area of that element towards its left side. So in that case, we will be calculating that area using the height of the current element, which is vector of I, times I minus left I. So I minus left I is basically going to be like, for example, we have 1 over here, right? Or we can say, let's say an example of 2. We have 2 over here. So since 2 can extend till 5, we will be storing the index of this 5 in that case, right? So for example, we have this 2 right here. So index of this 2 is 4. Index of this 5 is 2. So 4 minus 2 is going to be 2. So it is these two variable, or these two rectangles over here, you can say. So we are calculating the area towards left of 2, that is possible, which is going to be this area right here, using 5 and 6. And similarly, we will use the same thing for right, since if right is not equals to -1, which means we can extend it towards right as well. So we will be extending towards this 3, and we will be calculating the area using right of I minus 1, because it is storing the indexes on the right which are going to be greater. So you will have to subtract accordingly. So then we will be able to calculate the area on the right as well, and then we also have the current area of the current rectangle as well, which is 2. So we have calculated the left area, we have calculated the current area, and we have calculated the right area. Then you can combine these three, take a sum of these three, and then just check with the maximum area. If it is greater than the maximum area, then that is going to be the maximum area, otherwise the maximum area remains same, and then you can just print it out. I've also submitted my solution on lead code and it works completely fine. Not the best runtime, but not bad either. I got 33 milliseconds by my solution, so it is not that bad. Memory is also not that great, but I think this kind of works. This was my solution for it, or the solution that I was able to figure out. If you did not understand my solution by any sense, or if you just don't like it or don't want to use it, you think it is too long or anything like that, then you can check out solution of maybe like Neat Code or something, or some other YouTuber. You will be able to find ample amount of solutions online which work completely fine and well enough, so you should be able to check them out. Since my code works completely fine, I will just move on to the next question, which is question number 12. By the way, this 11th question, you should try doing it yourself. Obviously, if you can't do it, take help from anywhere. That's completely fine, but don't leave it. It's a very good question. The best one I have found so far in this set. Obviously, all the other questions were too easy. Even this one was not that difficult for me because I knew prefix and postfix kind of, so I was able to solve it. But you try solving it. If you can do it in like a single iteration as well, even better. You are quite smart, I would say that much. Now we can just move on to the next question. I will start solving it as well. I will mute myself now. You can also try solving it if you want to. Okay, so I have solved this question as well. In this, we just had to create a stack in such a way that we can get the minimum element in O1 time complexity. So I went with the simplest solution I could think of. I had an original stack which will function as a normal stack. Then I had one another stack which will act as a sorted stack. You can kind of say, and that is basically how I am doing it. So I have an original stack, a sorted stack, and another stack which will help us sort this stack. So whenever I'm pushing into this stack, I will be pushing into the original stack. Then I will be popping. Since in the sorted stack we want the minimum element to be on the top, we will be popping until the element on top of the stack is less than the current element that we have. Because if it is less than the current element, then we can't put it on the top. It will break the condition of monotonically decreasing, or whatever you want to call it in this case specifically. So you will just pop from stack 1 until you reach an element which is greater than the current element, and you will be popping and pushing those elements to stack 2. So they will be pushed to the second stack in reverse order. Then you will be pushing the current element in the first sorted stack. Then you will be emptying out the second stack and pushing the elements back to the first one. Basically, how we sorted the stack previously using another stack. That is basically what is going on here. And whenever we want the minimum, we can just return the top of the sorted stack. And whenever we want the top, we can just return the top of the original stack. When it comes to popping is also quite similar. We will first start popping from the sorted stack until we find the same element which is on top of the current stack. Once we have found that, we will pop it out of the sorted stack and we will pop it out of the original stack. Then we will again empty out the second stack and put the elements back in the first stack. That is basically how I did it. I don't know if this solution is good enough. Let me ask ChatGPT if this is a good solution for problem 12th. Although I don't think this one might be specifically, but we will see. So ChatGPT basically told us that we don't need to use the other sorted stack. We can just store in original stack, but it is not running a loop. It is just checking if the current element is smaller than the current element we have in the main stack or not. If it is, then it will be pushing it in the current stack, otherwise it won't. But this strategy specifically, I don't think this is going to work because for example, if you pop the current minimum element and then you again try popping the minimum element, now you won't be having the next minimum element because you did not have it in the stack if you were like pushing in reverse order. So I don't think that is going to work, but okay, maybe this would work. I am not thinking too hard right now. Anyways, we can just move on to the next one. You can also try solving it with me if you want to. I will mute myself now. Okay guys, so this is the next day. I have not attempted the 13th question yet. While I was sleeping yesterday, I kept thinking about the solution ChatGPT gave me, and it is correct. I don't know, I was high yesterday, or my mind was definitely not working properly. But anyways, this solution is correct by ChatGPT. Took me a second to understand it because, as I said, my mind was not properly working yesterday. I was tired. But anyways, you can try it out if you want to. This is the correct one. Mine is incorrect because we are not popping from anywhere in between. If we were, then it would have been correct. But anyways, now we can just move on to the next question. You can also try it out with me if you want to. I will also try and attempt it. Okay, so I am finally done with this question as well. This was the most difficult question among all of the questions because, first of all, this is a very like from the top explanation of the question. I tried searching for the real question on lead code. It's apparently for only you have to subscribe to unlock this question. But anyways, so since I did not know all of the conditions and everything, it was difficult to understand the problem completely. But other than that, just uh, thinking about how stack will be applied to it was also a bit difficult. So I took a bit of help from ChatGPT. Of course, after thinking myself for quite some time. I don't know. My head is just not in it. Since the past 2 days, I have been trying to correct my sleeping schedule, and maybe that's it. That is why I just my brain is not working properly. But anyways, so what we have to do in this question is we have to find a celebrity. So we are given an n by n square matrix, and in the matrix an integer I and j, for example this integer m I of j, if it is equals to 1, it means that the person I knows the person j. So we have to find a celebrity, and celebrity is a person who is known by everyone but who knows no one. So basically m I j, I can be the celebrity. So mi with any j has to be equal to 0, and mj with any I has to be equal to 1, other than m of mi of I, basically not the candidate knowing himself. That condition has to be ignored. So of course it is not mentioned here because as I said, this is very like from the top explanation, not quite clear at all. But anyways, so what I did for this question is I obviously took the input first of the square matrix. After that I created the stack, and in the stack I created all the indexes from 0 to n minus 1 in the stack, and from the top of the stack I am each time popping 2 elements, and with those 2 elements I am just checking if one of them could be the potential celebrity or not. And for them to be the potential celebrity, I check it with this condition. I check if ij is equals to 0. If ij is equals to 0, it means I does not know j, so it means it could be possible that I is the celebrity. So I push I to the stack. Other than that, otherwise if this condition is false, then j could be the celebrity, so I push j in the stack, and I continue until the size of the stack is greater than 1. So until only one element is left in the stack. Once a single element is left in the stack, it has to be validated, because it right now in the stack we are storing the elements that could be potential celebrities. So the last one left could be a potential celebrity, but we have to still check if it is a celebrity or not. For that we just have to check that candidate with each index, not by itself but each index other than itself. We have to check if it satisfies the celebrity condition or not. Basically with every other index we have to check if the candidate is known by that index or not, and if it does not know that index or not. If any of these conditions fail, then we just directly return false, otherwise we return true. It means it is a celebrity. So if it is the celebrity, then we just print out the number of that candidate, or the index you can say. Otherwise you just print out -1. So the only thing difficult in this question was figuring out if how to use a stack properly. I have never used a stack this way before, or maybe I have, I just don't remember. As I said, my mind is not working properly, maybe because I am slightly deprived of sleep. But anyways, so after the only thing was to figure out how to use a stack, and you can just store all the elements, pop out two from the top. So if we ever encounter a question like this ever again in the future, then we will be able to solve it. Hopefully we will be able to solve it. So anyways, this was it for this problem. Hope you tried yourself as well. If you got stuck anywhere, I hope the explanation that I gave was clear enough. If it was not, You can also ask ChatGPT for the solution or search somewhere else, it doesn't matter. Now we can move on to the last question. You can also try it out with me if you want to. I will mute myself now. Okay, so somehow I've solved this question as well. My mind is definitely not working properly today because I made a very obvious mistake in this one. Is that I had to put the while loop inside the for loop because we might have to continuously pop from the stack. And we have definitely solved enough questions previously to know that that is what has to be done. I think my mind is just not working properly today. But anyways, I will still explain the question and uh, the solution. So we just had to check if a given sequence of pushing and popping from the stack is valid or not. So this can be the sequence of pushing and this can be the sequence of popping. It has to be valid. At first I did not understand what it was trying to say. I thought we had to just push all of the elements first and then pop them. So after asking ChatGPT, I kind of understood it that you can pop an element and keep popping them, and you can also you can push an element and keep pushing them, and you can also keep popping elements at the same times if the sequence is valid or if it matches this sequence. So that is the way we solve this question. We just have to check for the valid sequence. So what we did is you can just push into the stack, and each time you can run a while loop checking if the top is equal to that particular index of pop or not. Basically the top of the popped one, you can kind of call it. You can also create another stack for this if you want to. You can call it the pop stack and put element into it in reverse and start popping accordingly. But anyways, so in this case I've just used the vector itself with an index j, and until they are equal we will keep popping them until that sequence of the popped array is being satisfied. And when we come out of it, we can just finally check if the stack is empty or not. Because if the stack is empty, then the sequence is valid, otherwise it is invalid. So that was it. So we have solved all of the questions of stacks, or all of the questions given to us by ChatGPT, curated by ChatGPT. The questions, the beginner questions and the intermediate questions were really easy. The only challenging ones were the advanced questions. In them, I think because these are advanced questions, so we need a better explanation of the questions as well. But they are very good questions to understand stacks and to be able to solve stack related problems in the future. I hope you tried solving it as well. If you have not, you can try solving it now. And with this we are done for today. Next I'm going to start solving questions of Q, I guess. So see you then. Any other than that, just keep practicing and have a good day.
So please whatever. Please I want to reach 1 million likes. So please Okay, thank you.